All right, this is 8.5 homework help. The first problem says we want to add these vectors together. So when you add two vectors together, you just add the, these are complex numbers. So when you add the two complex numbers together, you get 2 plus -3, which is -1. And you add the imaginary parts together, -3i and 1i make -2i. So you add them together just like you would vectors. But now we're dealing with complex numbers, you know, in the form a plus bi, where this is the real part and this is the imaginary part. Okay. Next question, when you subtract them, you have 2 minus 3i minus the other one, -3 plus i. So you distribute the negative sign just like you think you would. You'd have 2 minus 3i plus 3 minus I, in which case this turns into 5 minus 4i. So this would be 5 and this would be 4. I'm sorry, -4. Now when you multiply two complex numbers together, you just FOIL, just like you think you would. So for the next part, I end up with this, and I'm going to FOIL. 3 times -3. 2 times -3 is -6. 2 times I is 2i. -3i times -3 is a positive 9i. And then -3i times I is a -3i squared. Now we simplify this. So this is -6 plus 11i. And then this right here, I squared is really -1. Because I is the square root of -1. If I can write. So I squared would be the square root of -1 squared, which is just -1. So I is the square root of -1, I squared is just -1. So we substitute a -1 right here, and this gives us plus 3. Now we can add these together and get -3 plus 11i in standard form for a complex number, which is a plus bi. So my answer then is -3 and then 11 here. All right, the next problem wants us to do u divided by v. So we're going to take 2 minus 3i divided by -3 plus i. Now there's two different ways to do this. I'm going to do it one way, but I'll show you another way on the formula sheet later when we do the practice quiz, which is right here. You change it into trig form, which is not that hard. It looks hard, but it's not that hard to do. And then you just use this formula right here in trig form, which we'll go over on the practice quiz. It's really not that difficult. But for now, what I'm going to do is when I divide this, I'm going to multiply top and bottom by the conjugate -3 minus I. That's really multiplying by -1, or I'm sorry, it's really multiplying by 1, which doesn't change the quantity at all, but it does rearrange things. So to do this, I'm going to have to FOIL. So FOIL the top, and you get -6, -2i, positive 9i, and then positive 3i squared. And then in the bottom, if you FOIL the bottom, the middle terms are going to cancel because it's a difference of two squares pattern. You're going to have -3 times -3, which is 9, and I times -I, which is -I squared. Now I'm going to simplify this. So this is -1. So I end up with -6 plus 7i minus 1. So I'll add the -1 and the -6 together to get -7. And divided by, and then this is also -1. So 9 minus the -1 is really 10. Double negatives go positive. So my answer is -7 over 10 plus 7 over 10i, if I just divide the 10 into both. So that means I put -7 over 10 here, and I put 7 over 10 here. And I just made a mistake too. I forgot about that 3 right there. So -1 times 3 gives you -3, plus -6 gives you -9 right here. So this should have been -9. That's my mistake. In which case this would be a 9 right here. So the next one, v divided by u, I'm going to take this one and divide it by the other one. I'm going to do the same thing where I'm going to multiply by the conjugate, 2 plus 3i of the bottom, because that's multiplying by 1, so that doesn't change the quantity at all. But what it does is when you multiply a complex number by a conjugate, it gives us a whole number in the bottom, which is what we want. So let's FOIL the top. We get -6 minus 9i plus 2i, and then I times I times 3i is positive 3i squared. All divided by, in the bottom you have the middle terms cancel, so you have first times first, which is 4, and last times last, which is -9i squared. Let me simplify this now. This turns into this is -1, so I have -3 and -6, which is -9. and the middle terms make negative 7. And then in the bottom, this is negative 1, so 4 plus 9 is 13. So this turns into negative 9 over 13 minus 7i over 13. And so I'd put negative 9 over 13 here and negative 7 over 13 here. Okay, the next one, v squared. Now I'm going to do v squared regular. So I'm going to take 3 plus I, and I'm going to do times 3, negative 3 plus I, because that's v times v. That's v squared. So you get negative 3 times negative 3, which is positive 9, negative 3i, and I squared. That turns into negative 1, so this would be 8 if you add 9 and negative 1, minus 6i, so this would be 8, and this would be negative 6. All right, now for the next one, to the third root, I could do the same thing where now I multiply v times itself 3 times to get v cubed. What I'm going to do instead is I'm going to change v into, I'm going to use the formula sheet because this is what we're doing on the test and on the practice quizzes. I'm going to change this into trig form. So to change this into trig form, you can pull up the formula sheet. It tells you exactly how to do it right here. It's really r times cosine of theta plus I sine of theta. So I'm going to graph this trig number over here. This is, when you graph it, you graph the real part on the x-axis and the imaginary part on the y-axis. So what this trig complex number looks like is right here. You go back 3 and up 1, because it's like negative 3 comma 1 for the real and imaginary part, where the negative 3's coming there and the 1's coming from that coefficient. Now, trig form is r cosine of theta plus I sine of theta. So what you do is r is the distance away from the origin, which comes from the Pythagorean theorem. So that'd be negative 3 squared, which is 9, plus 1 squared, which is 1 square rooted. So r is the square root of 10. And our theta is what we rotate by to get to that. So what I'm going to do is do inverse tangent of 1 over 3, which right from this little right triangle where this is 1 and this is 3. And then I'm going to take 180 minus that. So that gives me about 0.322. Now keep in mind 0.322 is this angle right here, 0.322. And I want to do, I want this angle. So I'm going to do 180 minus that, which is pi minus 0.322, which gives me 2.82 approximately. So the angle I actually want is 2.82 radians. So my trig form is going to be the square root of 10 times the cosine of 2.82, now we're in radians, plus I sine of 2.82. Now if you're in radian mode and you go ahead and distribute this, you'll get right back to this complex number. You can go ahead and try it if you want. Another way to get the 2.82, by the way, which you might find easier, is to do negative 3 right here. Because if you do inverse tangent of 1 over negative 3, you will get right to the 2.82. So this might seem confusing, but like I said, if you distribute this, you get right back to what we're talking about. Keep in mind we're in radians, so I'm not going to write the degree symbol there. Now what you can do is go to the formula sheet, and once you're in trig form, you can find the product of two complex numbers, the quotient of two complex numbers, and even raise a complex number to a power very quickly with these formulas. That's the benefit of putting it into trig form. So what we're trying to find is the quotient, we're trying to find a complex number raised to a power. So we're going to use this formula right here. So now what we're doing is we're raising this to the, in this case, the third power. So what I want is this raised to the third power. What you can see is I've got it filled out just like this now, where my r is square root of 10, my theta is 2.82 radians, and my n is 3. It's my power of 3. So all I have to do is fill this out right here. And that's my answer. So it's going to be r to the n, which is square root of 10 to the third power, times the cosine of n times theta, which in this case is 3 times 2.82. Now I'm not going to round 2.82. I'm going to keep that number in my calculator. Plus I sine of 3 times 2.82. And that's my answer. They do want an a plus bi form, so I am going to have to distribute this now to both terms. This is something I'm going to do in the calculator. I'm going to do the square root of 10 cubed, I'm going to multiply by the cosine of 3 times that number in my calculator. I'm going to grab that without rounding it. And if I do that, that gives me negative 18, and this is 26i. If you take the square root of 10 cubed times the sine of 3 times that number. So this is my answer right here. Negative 18 is the real part, A, and B is 26, the imaginary part. What's nice about this is it works for every power. So I can go ahead and just do the same thing again, fill out the same formula for the 4th power, only now all I changed, the only thing that's changed is n, which is 4. So this would be a 4, this would be a 4, and this would be a 4. So I'm going to do the exact same thing now. Take the square root of 10 to the 4th power times the cosine of 4 times 2.82 and distribute that number to both this and this. And that gives me 28 plus negative 96i, as long as you're in radian mode in your calculator, because that's in radians. And that gives you the last answer right here. This is the A, 28, and the B is negative 96. So I am going to ask you to do this formula on the test, and we'll go over on the practice quiz again. So you're going to have to put a number into trig form for a complex number, and then do the operation from there. And you'll find it's a lot easier, especially if you raise this power like to the 20th power. If I raise it to the 20th power, then the only thing that changes in this formula is this goes to 20 now, and this goes to 20, and this goes to 20. The n changes, that's it. So it's a lot easier than taking the complex number, which is negative 3 plus I, and multiplying it out 20 times. You're going to find this is a lot easier, actually. It seems like a lot of work at first, but it's actually a lot less than multiplying it all out. So hope this helps.